Mid-air gesture sensing technologies have opened up a new interaction space for desktop display, tabletop display, and large public display. However, what the design space of mid-air gestures and surface gestures is, and how users may perceive the co-presence of these two types of gestures, remained unclear in the context of mobile interaction. In this paper, we present our research on user-defined surface and mid-air gestures for mobile text processing activities. We conducted a guessability study to investigate users' perception and usage of gestures in different mobile text processing tasks, in different interaction spaces, and with different handheld postures. During the experiment, user-defined gestures were recorded by video cameras and a leap motion sensor. We recruited 27 participants for the guessability study, all of whom had been smartphone users for more than a year. There are 4 major findings from the guessability study. Firstly, users had fewer consensuses on more cognitively complex tasks. For example, we collected different types of gestures for the copy operation, such as drawing a letter C, clicking on a pop-up menu, swiping up, and so on. However, people tended to propose similar gestures for more descriptive operations. For example, to move the cursor to the beginning of the row, most users performed the swipe left gesture. Secondly, non-physical gestures save actions for complex tasks. In our example of copy, the physical gesture of activating a pop-up menu and selecting the function on it required more than one step to accomplish, while the symbolic gesture of drawing a C only took a single action. Third, simpler gestures with less degree of freedom were preferred given a limited range of motion. For instance, the one-click gesture was widely adopted in all tasks in one-thumb interactions. Fourth, physical gestures were preferred given bigger ranges of motion. This was a surprising finding, as we had anticipated that users would use more non-physical gestures, such as drawing a symbol, when provided with more degrees of freedom. However, when participants signaled operations with their index finger, significantly more gestures proposed were physical, such as clicking. We further derived a set of mid-air gestures for mobile text editing, and developed a prototype with an ordinary mobile phone equipped with a leap motion sensor. The following video demonstrates this proof of concept prototype.